Welcome to class number 4. This is all about understanding drivers. In the first lesson, we start with the impact frequency illusion. You may have seen this from the former classes. It is the key driver canvas where we see the frequency of the topics customers are mentioning. So basically we count what they say, and the x-axis is the impact of those topics found by a driver analysis. And the impact frequency illusion is actually this paradoxon that now we ask the customers, why did you rate this way? So we should expect that they tell us why they rate this way, so we can count and can assume that the most often mentioned topic is driving the rating, right? That's why everyone in the world is counting what people are saying and then act on it. But actually, when you do the math, when you do the analysis of how predictive those topics and those information are to explain what people do later on, you see close to no relationship. Why is this? What's the reason for this mismatch? So, to be short, customers don't lie, not intentionally. They simply start talking. Yeah, it's like you meet a friend, you say, "How are you?" and they typically say, "Great," right? People start talking with the initial association they have with a question. So what we found is actually that the top ranked and the top frequent topics are basically strong associations with a category. So for Sonos, it's sound. For washing machines, it washes good. For insurance, it's great service. For food chain, it tastes good. So that's what we see across the board. Because that's basically what people have in their mind, and it's not wrong, yeah? Because basically they give you a basic reason why they consume your product, yeah? Because sounds good, tastes good, service good, price good, whatever is good. The initial association. But this doesn't mean that improving this will further drive your customer experience. Actually your customers, when you ask them, they don't have an incentive to really dig deep and to really answer what is the key thing which drove you to this rating or to this decision. Yeah, you simply have an open end and ask, yeah, spend a minute to fill it, right? So there are other techniques like predictive markets where you give the respondents an incentive, yeah, only if they find the truth that will later on they will earn money for that. Yeah, and in this kind of setting you may expect people dig really deep because it's in their own opinion, they earn money from that. So, but actually I think Danny Kahneman already told us humans are like cats. They can't swim, yeah, but they avoid it at all times, and that's basically the same for the thought process. Actually, the quote is, thinking like cats, they avoid swimming, but they can swim. A human avoid thinking, but they can think. Right? Because thinking takes such a large amount of energy, you basically avoid it at all times. And of course, there are also some topics people are not trained to talk about. Yeah? All kinds of behavioral triggers and behavioral mechanisms what you don't really talk about. Or you may talk about, but you're not really aware of what really drove your decision, right? So the whole concept of post-rationalization is that people try to explain their decision. They basically come up with a story that seems to be plausible, but they actually don't know why they decided. Yeah? But with analytics, we can now find out. So examples are, again, that the top frequency categories, they define the category most of the time. And what we also see is that either new or low performing categories have a low frequency. Yeah? So if you add here, for instance, for Sonos, there was a new feature called Voice Assistant. And most of the clients don't have it yet, right? So, of course, it cannot be so often mentioned. But when it was mentioned, it was super powerful. Same with low performing categories. So if you're not so good still at reliability of performance, then of course it's not so often mentioned. But few people may be experiencing a good reliability or be satisfied with the status it has. And with this, you can find out that this is a key trigger for their loyalty. So low frequent topics can be super powerful. So we discussed that we need an analysis approach to really find out which topics are important. And first thing you may think of is actually comparing promoters with detractors, yeah? Because that's the first thing we do. Humans learn by correlation, right? We do something and look whether or not an impact evolves. In the same way, we try to figure it out in other contexts. So we try to compare detractors from promoters, and where the difference is, we assume that's the reason, the causal reason for that. That's how you do it. But actually, it may work, but there's a large risk that it doesn't. Because it is a correlation exercise, and correlation is not causation. It can cause wrong signals. Actually, there is really a lack of differentiation because actually nearly every topic will correlate. Yeah? Every positive one is more often in the detractor versus the promoter group. So it's really hard then to find the key, yeah, because everything seems to be equally important, and it can even have sometimes wrong directional indications. I brought with me today two examples. One here again from this example of Sonos, where we saw regarding great sound, 61% of promoters were mentioning it, but 25% of detractors. So huge amount of promoters saying that. So it's an obvious sign that this is a key criteria to drive promotership. But actually, as you will see, it isn't. Yeah? It is a feature which people love. It's a reason why they choose it, but actually it is good enough. Improving the sound quality is not a key loyalty criteria. That's very clear from predictive analysis. So another example is that, for instance, for Sonos, 4% said bad support, and and 3% of the detractors say bad support. So that's even counterintuitive, yeah? So why should the promoters have larger complaints about it? Does it mean bad support is good? No. So actually there is another reason which you can really control with driver analysis. It is that new customers, they're basically are the larger percentage of those who take the support are newer customers, right? If you are a legacy customer, you know how it is. It's very unlikely that you will ask for support. So because of that, large amount of support is based on new customers, but new customers itself are always much more excited about the product. So there is a confounding effect of the new customer property, which distorts this correlation and it gives counterintuitive results. It does not allow you to correctly measure the importance of support. So in short, don't do that. Lesson number 3. So what we need is something like a key driver analysis. So the basic idea of a key driver analysis is that there are a set of possible drivers and each of them has a mutual impact. Yeah? And across many different respondents, we can separate out the different impact of that. And the basic form of the key driver analysis is the multiple regression. And many of you will know that. It is basically the idea that you have a formula, which is here the outcome, let's say the rating. Is determined by a driver. Let's call him driver 1. And this driver 1 gets a weight. Let's call this weight alpha. And there is another impact which will cause the rating, which is driver 2. And this driver 2 gets another weight. Let's call this alpha 2. For 1, alpha 2. And there are, of course, more drivers. So let's call them driver n, alpha n. And lastly, maybe everything is here 0, no impact. The rating would still be, I don't know, 3, right? So we need a constant, basically a fixed number, is 3, for instance, so that with no impact we arrive at a certain number. So that's basically the regression formula. Yeah. Here, for this variable, these are what the different respondents say. Yeah. For instance, when this D1 is quality, it's based on whether or not they stated quality, good quality, yeah, or the sentiment or whatever. This is what the customer is saying. And this alpha is a parameter. Yeah. So basically, the data, the drivers come from the survey. Okay. And the parameters, they are found by analysis. That's basically what the regression is doing. It finds those alphas so that it best predicts the rating of every single respondent. I will show you this as a visualization in a minute. But basically that's the idea of the regression, right? So it finds the weight is also then the importance, because actually only if, or basically if this weight is 0, it doesn't matter what the customer is saying here, right? So only if this weight is 0, this variable has no impact to predict the rating, right? So the parameter is also an analogy to the impact. So now, with some assumptions, you can now state that when we find that this parameter is high, then of course this driver 1 is causing the rating. Yeah? The idea of Granger was that we have an outcome, yeah, that's a rating, and you have the drivers. I simply driver 1, driver 2, I simply visualize that. That's the same thing. That's regression. So his assumption was basically, if we can assume that this is a cause and not this, right? If the causal flow is in this direction, and we can assume that there's nothing else influencing it, then this parameter we find, this impact we measure, is the causal impact. And with key driver regression, you have some more assumptions. You assume linearity, yeah, because basically this fixed parameter says the more the better. Yeah? The more D1 we got, the higher the rating, right? It's a simple weight. This weight basically assumes linearity. It also assumes that no matter what D1 does, D2 has this kind of importance. So basically, those causal impacts have nothing to do with each other. They are independent. These are the kind of assumptions made in this context. It's good to know that, because there are ways to circumvent them. Good. So the idea is that the drivers have a mutual impact. They are representative in some kind of regression formula. According to the Granger's idea, you can assume that based on some assumptions that what you find is causal to your outcome. And you should know the assumptions of linear regression, which is linearity of drivers, independence of drivers. Closed world assumption is an assumption based on the Granger's idea. Let's talk about nonlinearities, because the conventional regression assumes linearity, but oftentimes this is too overly simplistic, and there are ways to circumvent them. So the main types of nonlinearities, so there are actually a couple of them. So there is a hockey stick, which is this kind of shape. Then there is the saturation curve, which is this. Then we have a U shape, or an inverted U. There is an S curve, yeah, or threshold effect. And there is an inverted S, which is plateau. All of kinds of nonlinearities, and of course you can draw much more nonlinearities, of course. So there are lots of different types of nonlinearities, and the big question is always there, how do I know what kind of nonlinearity we have in play here? And basically the answer is use a method which finds it out. So this is exactly the limit of conventional statistics. When you hear a statistics expert, a modeling expert speak, they 95% of the day, what they mean is parameterized statistics. They mean to have a formula like the regression formula, and pimp this formula a little bit up, because you can basically build some nonlinearities in there. But you need to know which kind of nonlinearity you have and which variables have this nonlinearity. So actually, parameterized statistics is unpractical, not useful for business. So there are some techniques around, like the Shapley value regression, which is using a heuristic to model some nonlinearities. But also this technique has severe limits. So basically it slices the data space in 3 to 5 slices. So and the results very much differ where you put the slice. But even more severe, it is not stable for a larger number of variables. So it is recommended to up to 10 drivers. But actually in CX, when we have code books with 50 or more categories, it's basically not recommended. This is where machine learning comes in. Machine learning is a kind of a universal regression. It's simply the formula, which produces an outcome, like a regression, but the formula is not predefined. That's machine learning. It builds a formula based on the data. It is adaptive and can learn which formula best fits input towards output. Let me visualize machine learning. What you see here is regression. The more the better. It puts a fixed plane into the data space and finds the parameter which best fits the data. This is machine learning. It's a flexible plane tissue which is put in the data space and wrapped around the data so it best predicts outcome. Another challenge we have are interactions in data. Interactions are, you can view it as multivariate nonlinearities, but it's quite a simple thing. I really need to clarify the term interaction, because oftentimes people use it wrongly. So they mean interrelation. When they mean a driver 1, maybe friendliness influences service perception, and this influences loyalty. So they say, oh, these two, they interact with each other. They don't interact, they influence each other. So there's an interrelation, an indirect effect towards loyalty. And interaction is something very different. It could be, a better term would be basically, let me give you an example for an interaction. So let's assume we have 2 drivers. Let's call one driver quality, and the other driver is price. Good price, good quality. So and now you have basically 4 possibilities. Someone says nothing, See, basically he's not praising any of them. Here are the people who are praising the quality, Here are people who are praising just the price. And here are people who say, I love the quality and I love the price. Yeah? So now an interaction, one interaction would be that you will only see people really being loyal when they are satisfied with the quality and the price. Only if they mention both, they are loyal. Yeah, that's an interaction. Why? Because the importance of the quality now depends, or the impact of the quality depends on whether or not what the price is doing. So there is no individual importance of quality. There must be a good price as well. Both together only deliver a good customer experience, right? That's an interaction. An interaction is when there is no such thing as importance, when the importance is moderated by another factor. But the interesting thing now is you could think of a different interaction as well. For instance, that only those are loyal who say either quality or price. Yeah, because these are the quality buyers and this is the price buyers. When people are saying both, they are not loyal, because this is obviously when they have mixed perceptions and they cannot really make sense out of it. Something which is high quality cannot be high price or have a good price. So this would, there are markets where this is the case, yeah, where basically you cannot have both, yeah, and just assume that basically there are people who are loyal when they are good quality and others when they are good price, but when both come together it confuses people. So this is also an interaction, yeah, because you can have good customers with low quality and with high quality perception. It depends what the price is doing, right? So this is an interaction too. Yeah? This is basically an exclusive OR, yeah, logic, and this is an AND logic. So only if quality and price is given. The exclusive OR is either quality or price. So these interactions are possible, but the thing is, again, we don't know that upfront, right? And ways to handle interactions are, again, parametric modeling, statistics. You can adopt this kind of interactions in the regression formula, but you need to know upfront which variables are interacting, which of the 50 you have, and what kind of interaction is in place. Again, unpractical. That's why nobody's doing it. So, but machine learning finds this automatically out of data.
Lesson number 6, mediators in key driver analysis. So what is a mediator? A mediator is an intermediary variable, an intermediary outcome. So it's a driver for the outcome. For instance, it's a driver for likelihood to recommend, but it's also an outcome of other drivers. Yeah? So for instance, if you have great service as a category, great service is an outcome of friendliness, but both could be a driver to likelihood to recommend, right? So the great service is basically a higher level category. A typical other intermediary variable is the sentiment. It measures the tonality of the verbatims. And this tonality is, of course, a result of the different categories because depending on the category, they have positive or negative meanings, or they are filled with emotional or rational words. So they have very different tonality itself and not just a different rational meaning. So these are the different mediators in customer experience models. So why do we need to include them? There's a simple reason. The ultimate use is actually to measure the true impact of your drivers. Because if you just do driver analysis, which is a regression approach, is always only measuring the direct effects. Yeah, but if the drivers have interrelations to each other, you need to accommodate for them. You need to measure that. Yes, for instance, in this example here, great sound has no direct effect, but it's still important. Why? Because it is a very emotional variable, and basically any information of impact is also measured by the sentiment variable. Yeah? So there's an indirect effect. And to understand the full effect of a driver, you need to model the direct and the indirect effects. This also not only helps you to identify the true impact, but also you are understanding the true meaning. Yeah, for instance, for this example of great sound, we learn that people don't mean that the frequency spectrum is great, but they mean they enjoy the music when listening to it. So you really understand the meaning. There's another example I'd like to share. We did this exercise for a company who rents out flats, and you want to know, okay, how can we improve the loyalty? And one of the key drivers was the location of the flats, right? And it turns out that what the great location perception really means very much depends on many different factors. One of them is the gardening. Is there a great garden around? Are there trees and little park or so? And this very much influence whether or not someone who rents a flat would attribute that it has a great location. It's not just that there is an underground in the near or a known highway right across, right? So you measure better the impact and you understand better what the actual meaning of the category is. So, and here are some software packages who can help you measuring so-called indirect effects. So they enable you to integrate mediators. This is, for instance, PLS, path modeling. Software would be something like Smart PLS. Then there is structural equation modeling. Software would be M+, Amos, Listral, something like that. Then there are Bayesian networks. Software is, for instance, Bayesian. And there's universal structure modeling. The software for that is Newsroll. So this is actually the software I have developed 20 years ago and is developing further every year.
Let's talk about how to validate the different approaches. First off, there is the predictive power measured by the R square of a driver analysis. But be aware that the R square and the predictive power only measures the validity of the direct path, the direct causal path. It does not measure the importance or basically the role of indirect effects. So basically you need to look at the R square of any variable which has drivers. So in the causal context there are these intermediate variables like sentiment as well as the final outcome. And to fully understand the full network you need to look at all of those outcomes. Beside the predictive power, you want to always check also the cross-validation. It tries to check for overfitting. If you have a small number of data, but a large number of drivers, there is a risk of overfitting. And yeah, those modeling approaches, also machine learning, they can be shipped with techniques that try to minimize the overfitting risk. But still, it's always good to check that out, how large the overfitting really is. And cross-validation is one approach. Another term is jackknifing. It basically takes out, actually it takes your data set and splits into, let's say, 10 different pieces. You always take one out, compute the model with the rest, and predict the part which you have taken out. And then this you do with the other parts as well. So, and across this prediction of the not seen data, you can calculate basically the predictive power of unseen data. It's a cross-validation methodology. There's another thing called impact versus effect strength. So one thing is that you can, of course, measure the impact in terms of how big is the effect. Basically, this means how much will the rating or the NPS improve when I improve the driver by 10%. That's basically impact. But still, especially when it comes to interactions, that's not so easy, because if the impact of a driver depends on another driver, you cannot simulate it this way, right? You would basically need to simulate both at the same time. So there's a measure called effect strength, which actually simulates what would happen with the predictive power if I get rid of a variable. And that's a placeholder for to basically measure the overall importance of a variable in a model. And with this, you can also find what's really the importance of a variable, even if it has a low impact. Let's summarize class 4. So we have an impact frequency illusion. This means that the most often mentioned topics are most of the time not the most important ones. So this is why we need driver analysis. Using correlation and simply comparing frequencies between promoters and detractors has a high risk of fooling you. I gave some examples for that. So it is a must to use a key driver analysis, and it's always good to at least use a regression type of analysis. But there are certain tricks and traits which actually will improve your predictive power of those key driver analysis by 100%. You can improve it by 100% by considering nonlinearities, considering interactions, and considering mediation effects. And this can be done the best and the easiest and the most practical way using machine learning. So we talked about validation. You should look at predictive power, but not only that, follow the predictive power through the causal network. Thank you very much.